ascending, descending, and horizontal solvent flow chromatography are techniques deployed in thin layer chromatography, gas chromatography, paper chromatography, and column chromatography. Yeah, so let's start discussing, bring the answers in. Hannes says column.
Would be column.
Explanation? Do you have an explanation for it?
No.
Sorry?
I don't have a proper explanation, but I know it can't be gas chromatography. That one is out.
Okay. So we can go with that. We don't have an explanation for it.
I checked it was paper.
It was paper. What's your explanation? Have we gone through these chromatographic methods before? Okay, if we have not gone through it, let's start discussing. Anyone has a good summary for chemistry?
Okay, I don't know, maybe briefly what I can think of. There is HPLC, there is thin layer, there is paper chromatography and gas chromatography. Someone can pick up from there. I think HPLC is part of column as well, if I'm not wrong.
Okay, yeah, someone else. Please let's talk and discuss because we still have the other mock papers and time is limited. Okay, this is something I found on Google. I sent to the group. The first one we have gas chromatography. It has a mobile phase and a stationary phase. So for the mobile phase, it's inert gas, and the stationary phase is a column within a machine. And then for gas is ideal in scenarios where there's need to separate volatile mixtures in pharmaceuticals and all that. So we have said for gas, they have the mobile phase, which is the inert gas, and the stationary phase, which is a column. So it's ideal when you're separating volatile mixtures. For high performance liquid chromatography, this method is favorite in many labs because of its efficiency using a liquid or a solvent mobile phase. So the mobile phase in high HPLC is liquid or solvent that pushes the sample through the machine using a high pressure pump. For this, it's best for scenarios requiring non-volatile mixtures. Yeah, so for this one, the mobile phase is liquid and solvent. Remember that, and high performance, so we use high pressure. And this one is applicable for non-volatile mixtures. For thin layer chromatography, we use a silica gel or aluminum as the stationary phase and coat it on a thin glass or plastic. On the other hand, the mobile phase is high performance liquid chromatography in that it uses either single solvent or a mixture of solvents. Yeah. So we use it for like small experiments. We all know this is one of the most common chromatographic methods, even in pharmacognosy. So for analyzing liquid or solvent compounds and number of component impurities, so it's used in all that. Then lastly, for paper chromatography, the mobile phase is a solvent or a mixture of solvents, and the stationary phase is a paper. So not just any paper, we need an absorbent piece that allows the liquid to pass through the pores. It's used in forensics, DNA print, fingerprints, remember with that. Yeah, so that's all I have. And someone sent ascending chromatography. In ascending chromatography, the solvent mobile phase is added to the bottom of the column and it travels upwards through the column. As the solvent moves through the column, it interacts with the sample, which is loaded at the top of the column. The components of the sample separate based on their interaction with the stationary phase and the solvent. This is common method used in column chromatography. For descending, this reverse of the ascending that we have said, the solvent is added to the top of the solvent is added to the top of the column and it flows downwards through the column. So this one is descending, it's going down. And the same principle apply. For horizontal, we use a column or a plate where the solvent flows horizontally through a flat face, and this method is less common than ascending and descending. Okay, so for ascending is the most common one is column, and for descending, I don't know.
That's why I was saying the answer for me looks like D. It's not C necessarily. Column chromatography, because column chromatography, I don't know, it feels like the right answer to me. I don't know why.
Go with column because the column is the one we have said is the most common in ascending. You can stack that question. In quantitative analytical, okay, one thing, ascending, descending, horizontal solvent flow chromatography are commonly associated with a type of chromatography known as column chromatography. Yeah, so I think it has been decided. In a quantitative analytical assay, the number of determinants that must be performed in order to conclude on the value of determinants is C. Any explanation for that? Yeah. Someone has sent. According to a presentation on ISO, whatever, the minimum number of determinants must be performed in order to conclude the value of is a least two acceptable measurements or results for each laboratory sample according to okay. So the ones who are saying 3, do you have a difference for that or an explanation?
From practice, I have no literature or anything backing it up, but just what is routinely done in the lab.
Okay, my thinking is because we used to do in chemistry, we used to do 3 titrations and then we'd get the average of the 3 to find the actual value. So that's why I think it's 3. Because we used to do 3 and then you get the average. Yeah.
Oh, that's what it meant. Okay. Next, which one of the following spectroscopic methods uses radio frequency detectors in its recording system? Nuclear NMR, mass spec, X-ray diffraction, and differential scanning calorimetry. Okay, Shrina, we can put the answers A or since no one is discussing. An ideal method of extraction of thermolabile compounds is air hydrodistillation, ultrasound-assisted extraction, pressurized solvent extraction, and Soxhlet. Hiral says ultrasound. Rafina D, Soxhlet. Okay. They're all different kinds of answers. Please explain your answers.
For Soxlet, why would you use, because it's thermal, it's not as like thermal level is it heat stable or not heat stable?
It's heat sensitive.
Not
Yeah.
heat stable, right? Then you can't, I don't think you can use Soxlet because you're not directly heating you're not directly heating the compound, but there is yet heat.
Okay. So Soxalet is out and hydrodistillation uses heat also.
I think so. I went for B because I thought there's like no heat, but I'm not too sure.
Pressurized uses, I think, pressure, but also that will affect the thermolabile compounds.
I agree with the ultrasound.
Ultrasound.
Wait, pressurized solvent extraction. So the principle involved in this technique is that the application of high pressure maintains the solvent in a liquid state beyond its boiling point. So why wouldn't we use that?
Pardon?
Pressurized.
B is more yeah, I was reading the principle for pressurized solvent extraction. So the principle involved in this technique is the application of high pressure maintains the solvent in a liquid state beyond its normal boiling point. So does anyone know the principle for the ultrasound assisted extraction?
I think the pressurized solvent extraction is creating a temperature that is higher beyond the boiling point of the solvent, or rather of the compound we have. And in a thermolabile thing, we don't want that kind of situation. But that's basically super boiling or superheating, and you don't want that to happen because you'll destroy your extracts. Ultrasound has no heat.
Ultrasound has no heat. What's the principle behind it?
Sonication. I don't know if you've seen the sonicator. It moves around. It shakes the preparation that you have for like 48 hours. I don't know the principle exact in the exact words, but the shaking, I think, creates some sort of settling of different components in a preparation that you have. I don't know the exact rather the word for word principle.
That's okay. So we can go for the ultrasound. Have we discussed these methods of extraction in pharmacognosy? The conventional methods and the new methods. Black Panther says passing ultrasonic waves through a liquid solvent containing particles for ultrasound. Shrin, have we done these methods before? Okay, then I think we can go through that. We can go through the new methods, the conventional methods, and also the ones that we use for essential oil extraction. Okay, someone says the conventional ones. Those ones are the Soxlets, maceration, and all those ones, right? I think the conventional one is like That so like we discussed the conventional, the non-conventional, now the new automated extraction methods, like that pressurized ultrasound. Okay, just to mention the ones for that automated, this supercritical fluid extraction, pressurized liquid extraction, microwave assisted extraction, ultrasound, accelerated solvent extractor, enzyme assisted extraction, and pulse electric field extraction. I don't know the principle behind it, so maybe someone can explain it. Okay, so then we go on. Which pathway is used to biosynthesize detoxygenin, shikimic acid, phenyl propionate, cinnamic acid, and mevalonic acid pathway?
Google is saying mevalonic acid is the precursor in the biogenesis of digitoxygenin.
Okay, what were the different, these two, the shikimic acid and mevalonic acid, what were the products that they excrete differently, like the plant metabolites? Aromatic compounds such as aromatic amino acids, vitamin K, ubiquinone are important precursors for the metabolism of an organism. All organisms can synthesize these aromatic metabolites through shikimate pathway except for mammals. Which are dependent on their diet for these compounds. We're talking about mevalonic acid. I think the two types, the shikimic acid and mevalonic, were the ones who were using, like that synthesize this these plant metabolites, like what is it, glycosides and all that. So shikimate is the one for aromatic amino acids.
Shikimic is the one for phenolics, like flavonoids, like those ones is for shikimic. Mevalonic acid is for steroidal compounds and cholesterol.
Okay.
I think carotenoids, they're even terpenes, yeah. Yeah, terpenes also is for mevalonic acid.
Can we get like a table which says that if now with like this pathway synthesizes this and this other one to make it easy to remember?
Unless we Google that, I don't have it now.
Okay. Okay, so shikimic acid is a precursor for aromatic amino acids that has been said, tyrosine, tryptophan, and phenylalanine. Also for indole and indole derivatives, alkaloids, phenylpropanoids, flavonoids, tannins, and lignins. So that's the shikimic acid pathway. Okay, anyone else who has something to add on that? Then we can continue. The goal betters the skin test is an assay method for tannins, saponins, phenolic compounds, and alkaloids. Tour says tannins. Okay. Okay. Which of the following alkaloids is not a heterocyclic? Nicotine, cocaine, quinine, and ephedrine. D. Ephedrine.
Daktari, maybe we can
Followed
remind
Sorry?
ourselves. perhaps we can remind ourselves of the classification of the alkaloids. Then also on the previous question, we've said that the gold beaters test is for the tannins, but we can revise the other tests for the alkaloids, the Kinahagas, Wagner's. Especially, I know Kwanza alkaloids is a very testable topic.
You can take us through that.
I would,
Yes.
I would, but in
Summarize it for us.
the presence of Asmahan, I feel inadequate. So I'll let Asmahan take us through alkaloids.
Okay, Asmahan, you have been chosen.
I'm not conversant with that topic. She wouldn't say.
Really? Okay.
But see, I will say the little I know, then Asmahan can take over.
Yes.
So, okay, when we're talking about alkaloids, we know that essentially they contain that, based on the structure, chemical structure, that they have that nitrogen in a heterocyclic ring. Yeah, those are what we will refer to as the true alkaloids. Then there are the pseudo-alkaloids. Think pseudo-alkaloids. Wait, is Stanley here? You know, so Stanley is another. Okay, I hope they will add to what I'll say. Just wanted, okay. Yeah, so true alkaloids, they will have that nitrogen group in a heterocyclic ring. Then the pseudo-alkaloids, and the true alkaloids will be derived from amino acids. That's a characteristic of true alkaloids. They derive from amino acids and they have that nitrogen in the heterocyclic ring. But for the pseudo-alkaloids, these ones, they are not derived from the amino acids. They are not derived from the amino acids. Yeah. I believe there was another class known as proto-alkaloids. These are now in this class, they are derived from amino acids. However, the nitrogen atom is not part of the heterocyclic ring. So true and proto all derived from amino acids. The difference is the nitrogen ring, but the pseudo-alkaloids here, we say the pseudo-alkaloids, they are not derived from amino acids. A good example would be this, the one we've just said here, ephedrine. Ephedrine would be classified as a pseudo-alkaloid. Now, based on the classification, based on the structure, now we have the different types of alkaloids. We have the pyridine alkaloids, which the most common one there I know is the lobelia. Yeah, the Indian tobacco, also known as the Indian tobacco. The pyrrolidine. Pyrrolidine will have nicotine. The quinoline, of course, will have the cinchona, the quinine, and the quinidine. The isoquinoline will have the likes of morphine. The tropane, we have the atropine. The purine will have the caffeine. Yeah. Then on the test for alkaloids, I just know those tests, Bana. Hager's, Wagner's. So I know the Hager's test, it will give a yellow precipitate, but the other ones, the three of them, that's the Mayer, the Wagner, and the tannic acid, they usually give some white precipitate. Yeah, and then the Dragendorf reagent test. But so someone can add on to the same, please.
Okay, ephedrine is a proto, not pseudo. And then the pseudo, just to add on what you said, not derived
Mhm.
from amino acid, but they do have that heterocyclic ring.
Wait, pardon on the ephedrine?
It is a protoalkaloid.
It's proto, not pseudo.
But I've seen that,
Ephedrine is a pseudo-alkaloid.
yeah, I think it can be classified as both, I think.
We can know, like, does it have a heterocyclic nitrogen? Then we can know if it's like proto or
No,
pseudo.
from here it says it has a basic carbon skeleton of which it's not derived from amino acids. So, and then they don't have heterocyclic ring also.
So if it doesn't have a heterocyclic ring, that makes it a proto. But if it's not derived from amino acid, that makes it pseudo. I don't know.
Did guys mention that about tropane alkaloids?
I think you did.
And pyridine alkaloids? That's
Yeah, the
And
tropane alkaloids, it's the atropine, cocaine, iosine. I think the atropine.
yeah.
I think you mentioned them.
Okay.
But he covered everything except that the drag and drop tests. He didn't mention the precipitate. It forms orange reddish color with alkaloids, and the rest, as he mentioned, the Meyers, the Wagners, and the tannic, they form a white precipitate, except Heger's, which form a yellow, crystal yellow precipitate.
also, it is extracted using chloroform and ethanol.
We can continue. Or like anyone has something to add on? Meyers, white, yellow, Haggers, yellow, Drangendorf, orange, red, brown, Wagner's brown, tannic acid, puff colored. Okay. Which Shina can continue. The following oils are used in aromatherapy, are classified as reviving oils except chamomile, eucalyptus, lemon, and rosemary. Do we use lemon as aromatherapy? I don't know. Lemon, yeah. But I think it's used in candles also. So but what is the meaning of the reviving oils? Maybe that's the term here.
So, wait, just a moment. I was searching. But I'm assuming the reviving
Chamomile.
oils are like the essential oils. Am they not the same thing?
Yeah. But maybe the reviving, I don't know what that means. Chamomile is used for
Reviving.
inflammation. Chamomile is used as sedative. Yeah. Chamomile also decreases anxiety, something to do with it.
But I think the answer is lemon. I can't find anything.
Why would you go with lemon?
Like literally when we are classifying essential oils, lemon under it's okay. Me, I'm going by the
Elimination.
notion that these reviving oils are the same as essential oils. And I don't think I've ever okay, it's there. There's lemon oil. Chamomile, eucalyptus, lemon oil. Rosemary.
Were due to the uplift essential oils like peppermint, eucalyptus, citrus oils, such as lemon, orange, and rosemary are often considered reviving due to their uplifting energetic sense. Chamomile has a calming effect, not reviving. I will go with chamomile because the one. Yeah, I think even chamomile is the one which stimulates sleep. Maybe we go with chamomile. Okay, we can go with chamomile and continue. Which of the following is a toxic agent found in cassava? Mescaline, amygdaline, linamarin, and colchicine. So linamarin. Okay, we can discuss amygdaline. Where was it? Mescaline. We can discuss the other choices. Colchicine is no. Someone can tell us where amygdaline is found and mescaline is type of an alkaloid.
I think amygdaline is from bitter almonds. I don't know the name. I've forgotten the name. Rather the scientific name for bitter almonds.
Okay, someone also says Magdalene, bitter almonds.
Then
Mescaline is a halluc.
peyote
Sorry?
from the cactus, I think.
Or hallucinogenic and intoxicating compound present in peyote cactus. So mescaline, hallucinogen, and it's found in peyote cactus, and amygdalene is found in almonds. Colchicine, it was the drug that was being used in. Okay, colchicine, is it an alkaloid, Ama? It's a question. Okay, guys, what type of alkaloid?
It's one of those non-heterocyclic alkaloids. Like the nitrogen is not in a heterocyclic ring.
So it's a proto. Proto is the one you said it doesn't have the nitrogen drinks, yeah.
Yeah, but I think now the best term for that would be atypical alkaloid.
Okay. So linamarin is a Cyanogenic, question mark. Yeah, someone has answered that. C, autumnale. Okay, what's that? Hannes?
Fatma, I can see
Source
from
of
here
colchicine.
colchicine is an amino alkaloid. It's derived from 3-ring amine alkaloid.
Okay. So,
Colchicinium autumnale is the source of colchicine.
okay, Colchicina autumnale. Yeah, that's the word, the scientific name. The most active ingredient of catha edulis is merocathin, cathinone, cathin, and cathedulin. Can go with that. Ethnopharmacological fieldwork involves all the following except interviewing traditional healers, interpreting traditional terminologies, administering herbal remedies, and examining patients consuming herbal remedies. So, ethnopharmacology refers to the scientific study of natural occurring resources such as medications by ethnic or cultural groups. The main aim is to discover effective drugs based on the therapeutic use of plants by indigenous people.
I think C is going to be the right answer.
Yeah. It's like you're collecting information, not administering, right? Yeah, so you can go with C. Which of the following is not an element of bioprospecting policy? Benefit sharing among concerned parties, traditional application of the natural product, capacity building for value addition, and source of funding. Okay, Google. It's the exploration of biological material for commercially valuable genetic and biochemical properties. It's defined as a systemic and organized search for useful products derived from bioresources, including plants, microorganisms, animals, that can be developed further for commercialization and overall benefits of the society. So benefit sharing among concerned parties, traditional application of the natural product, capacity building for value addition, yeah, source of funding. Okay, is the benefit shared among just the concerned parties? I will personally go for A.
Yeah, because I've heard here it's written bioprospecting contracts lay down the rules of benefits, sharing between researchers and countries, and can bring royalties to lesser developed countries.
Okay, so the benefit is, that's the old one out here.
Maybe, yeah. Ama?
Yeah, I also think
Kama,
not
does that
D.
mean even maybe the less developed countries are also part of
I
the
think is the order
Is the
out
best
because
answer.
for benefit sharing, it's one of the ethical consideration in prospecting practices. I don't know that's what Google is saying.
What are the other ethical considerations? Please share if you have it or something.
No, I just Googled the
What's
benefit sharing. Is it part of bioprospecting policy?
I think a big part of this is usually just about intellectual property. Are people benefiting from what they know? Are the sources being protected, as in conservation measures? I think that's as far as my brain can go, but it's usually more about intellectual property. Are people being paid? Are people being credited? Is the environment being protected? Something like that. Like it's more or less about ensuring that the source of information is benefiting as much as they can in whatever way. So I don't know.
Which one would you go with as an answer here?
Either B or D, because again, either B or D. So picky ponky.
you said B or B, traditional application of the
B
natural
or D.
product.
Yes, traditional or source. So B or D, and then now picky ponky. I'm not sure.
Okay, I will go with D. Ego is also going with D. So our majority says D, Ama.
Yeah, I think D.
Nightwing says B. Do you have an explanation?
Because okay, I'm just reading from an article. Bioprospecting is a targeted exploration and search for as yet undiscovered chemical compounds, gene and their products within wild species and biological organisms for certain use with potential for commercial development. So it's linked to conservation of biodiversity. Bioprospecting often downstream screening, testing, and development of activities following the discovery of a potential useful substance, gene, or organism. So I think D.
Okay. Cannot be B because knowing the traditional use of the plant is an important predictor for what it can be potentially used. Okay, I don't know if you guys are getting the same, but I'm getting there are like 4 phases. Phase 1, collection of the sample. Phase 2, preparation, where there's isolation, identification, and characterization of the compound. And then phase 3 now is screening. So I think that's where you will now see if it can work. And then for phase 4 is commercialization. ChatGPT. The source of funding is not typically considered an element of bioprospecting policy. Instead, it pertains to the financial resources required to support bioprospecting activities. From which come from various sources, including government, research, investments. The other options are related. Okay. Then we can go with D. In the quality control herbal products, all the following are important parameters except total ash value, acid soluble ash, water soluble ash, and foreign matter. So we can remind ourselves these terms and the application in pharmacognosy. Okay, quality control. monogram guidelines, botanical and sensory evaluation, foreign matter should be free from if possible and microscopy. For physical chemicals, there's TLC, ash, total acid, acid insoluble and water insoluble, extractive matter in hot water, cold water and ethanol, water content and volatile matter, LOD, I don't know what that means, volatile oil steam distillation. For pharmacological, we test the bitterness value, standard solution of quinine hydrochloride. We do the hemolytic test using saponins. You refer with saponins because saponins are the ones which hemolyze. And then astringency, fraction tannin that binds to standard hide powder, swelling index in water, and foaming index. So we need to define these terms. Yeah, kindly share the photos on the group so that the people who are not here can use it. So definitions.
I love using the names of stuff to describe them. So total ash value is what remains after incineration or combustion. So of course, you usually take your sample and you burn. I would say the organic part will get combusted, and then whatever remains is the total ash value. Acid soluble, is it acid soluble or acid insoluble? I'm not sure. Acid soluble matter, acid soluble ash. No, water soluble, first of all, water soluble ash is that organic matter that when you take, the moment you've gotten your total ash, or rather the ash that you remain with, put it in water, dissolve, and then filter. So whatever remains as the filtrate, whatever remains as the residue, becomes the water insoluble ash, and then whatever goes into the water is water soluble ash. So I don't know if it's acid insoluble or acid soluble, but again, it is usually an inorganic part. I'm not sure whether it's insoluble or soluble. Someone can help us understand. My answer here would be D. Or B, I'm not sure.
I don't think it can be D, because for any product, whether it's herbal or
It
pharmaceutical,
has to
you'll
be
always
pure.
see if there's a foreign matter.
Yeah.
From the list we saw, I think acid soluble ash is the one that's not mentioned.
Okay. You think it's acid insoluble or something like that. It's not acid soluble. So.
Yeah, that's the odd one out of this.
Okay, do we all agree? We can go on, Basi, and that's question for 76. Guys have sent something, so you can go through it later. But from far, I can see the financing is part of it. In the microscopic examination of phenyl 1, one will expect to see granular trichomes, microsphendle crystals, elliptical vitae, and cicatrix. Answers. Becky, if you have anything to say, you can unmute. Maybe we start defining these terms before answering the question. Okay, we can go on if no one has anything to say about it. We'll come back to it. In the botanical name Assa palmatum, the epithet palmatum refers to originating from the palm tree, shaped like the hand, originating from the coast region, and the Latin name for marble. If you have anything to say, you can just unmute. It will be better if all of us are active and we finish the paper. We move to the next thing. B, shaped like the hand. Okay. Okay, we can go with B. Actually, not no, or 79 B. 78 we haven't answered. And then for number 80, suberin is found in the stem, cork, roots, and fibers. The root epidermis and the root endodermis. So yeah, for 80C. Okay, I can see like some say the cork and the others say that the root. Suberin is a waterproofing waxy substance found in higher plants. Suberin is the main constituent of cork. And what's the difference between the suberin and the cutin?
For that question on suberin, I'm finding it's found majorly in the roots, then followed by the cork. So both of them seem to be correct answer. To be correct answers.
So the main one is the root, you said.
Yeah, because it's found in the root epidermis and root endodermis. But then you see from what who is this? What Palestine has sent. They're also saying it's the main constituent of cork. So both answers seem to be correct.
Okay. So we can go with roots if it's mainly found in roots.
It's found in the root, cork, and bark tissue.
Mm.
And the bark is
but
found in the stem. So
Okay.
it's a
So what I'm
very
finding is
Mhm.
it occurs in the wall of the cork cells that form the skins of many roots, such as potatoes.
so cork is the main one.
Yeah.
Okay, so
Honey consists mainly of sucrose, liquid glucose, invert sugar, and cane sugar.
invert sugar.
The types of sugars found in honey is you said the invert
Fructose
is
and
the main one.
sucrose.
C, invert sugar.
C. It's invert sugar.
Invert, so
And the two main types are fructose and sucrose.
fructose and sucrose.
Sucrose.
So C.
What
Shrina,
does
C.
invert mean?
What does?
Invert sugar.
Fructose and
sucrose.
He's asking what does invert sugar means.
Mixture of fructose and fructose.
So it's a mixture of fructose and glucose, invert sugar. So pineapple can be classified as a aggregate fruit, multiple fruit, simple fruit, and dehiscent fruit. Rami says multiple fruits, multiple fruit. What are the types of fruits, if you can discuss that? Multiple fruit. If anyone knows the other types, we can discuss this. Okay, fruits can be classified as simple fruits derived from one ovary, aggregate fruits derived from multiple ovaries of single flower, multiple fruits from many flowers packed together, such as pineapple, blackberry, and raspberry. So simple from one ovary, aggregate from several ovaries in one single flower, and multiple from different flowers. And there is that descent, whatever, is it a type of fruit? So dehiscent fruits are dry fruits that open up at maturity in order to release their contents. The pericarp of dehiscent fruits split open upon the release of seeds, e.g. poppy and legumes. Yeah, so dry fruits that upon maturation release contents. That's the meaning for the. Anyone has anything to add on it? Okay, this is a
And then
diagram that was been
there's
sent.
indehiscent fruits also. There are those ones which do not split open at maturity and the seed remain enclosed within the fruit. Examples are sunflower seeds and grains of rice.
Grains of rice and sunflower. So
Sunflower
it
seeds.
doesn't release.
Yeah, it doesn't
Yeah,
release
okay.
the seeds. After maturity, the seeds remain enclosed within the fruit.
Okay. So here I'll send the diagram, simplifying it. So simple, we said from one ovary, aggregate, we said from different ovaries of one flower, and multiple from different flowers. And then for simple, we have dry and fleshy. For dry, we have discussed that you can check, you can look at the examples on your own later. Dehiscent, in dehiscent, we have said sixocarpic, I don't know what that means, and the fleshy are the berries, and always in dehiscent. So the fleshy are always meaning they don't release their seed upon maturation. Yeah, so you can go through this later. Tina, can you continue? Have you captured that? Okay. Which one of the following statements relates to wet granulation? It's suitable for processing its sensitive active pharmaceutical ingredients. And then, okay, someone, do you want to add to what you're saying, Ama? We can't hear you.
Sorry, I unmuted.
Okay. So it's your echo. Which of the following statements relates to wet granulation? It's suitable for processing heat-sensitive active pharmaceutical ingredients. It may be carried out using volatile solvents as granulating fluid instead of water. It's performed using roller compactors, and it's suitable for reducing flowability of primary powders. So what are the types of powders? When do we use dry? When do we use wet? We can discuss that. Gaia says B, it may be carried using volatile solvents such as granulating fluid instead of water. So some I think we covered this granulation stuff. Someone please summarize it for us. Okay, Shirina sent a table, wet versus dry. Dry granulation is the process of forming granules without using any liquid solution, and wet we are adding a granulating liquid. For dry, it involves direct compression of a fine ground powder, and this one for wet, it involves mixing with the fluid followed by forcing through a sieve to make tablets. So and then requires finely powdered compound, tablet pressers or roll compactors. And for wet, it requires powder particles, a granulating fluid, and a sieve, because we said first you mix with the granulating fluid and then it goes through a sieve. For dry, required when producing tablets from high moisture and heat sensitive compounds. So for dry, we use them when we're dealing with high moisture or heat sensitive compounds. And then for wet, required to avoid the destruction of the active components in the powder. Oh, so we use dry when we need for heat sensitive compounds. And then for dry granulation and wet, dry mixing, sludge compaction. And then for wet is aqueous and non-aqueous. Is that okay? Anyone has anything to add on that? So we move on. Which one of these mills is best suited for combination of fine powders? Kita mills, ball mill, roller mills, and hammer mills. Is it the roller? Just from what we have done for dry, it was saying we require fine powder, so we use roll compactors. Okay, Google says ball mills can be used for both wet and dry grinding and can produce very fine powders. Ball mill, hammer mill, and a attrition mill are used for fine. So, what do we go with? You guys see, we discuss so that we can finish. I know you guys have this content, so please share what you know. Ball milling is a mechanical technique widely used to create powders into fine particles. Becky says D. Now, what's your explanation for saying D? Okay, we can go for ball since for 83. Oh, she's saying B for 83. Sawa. So for 84, we can go with ball mill from Google. Now we can continue.
Then that's a content like we agreed for B because it's carried out using volatile solvents. Now someone says that it is suitable for reducing flowability of primary powder. So is it B or D?
Maybe Becky, explanation?
On that, I thought granulation in general is used to increase flowability of powders. Perhaps Becky can enlighten us further.
Yeah.
I don't have any explanation to that, but I could have gone with it is suitable for reducing flowability of primary powders. Because we have the wet and the dry granulation, but mostly the wet is used to increase the flowability.
Increase or decrease? Google says generally granulation transforms fine powders into free-flowing dust-free granules that are easy to compress. Is that okay? Can you continue? Okay, what component in the Noyes-Whitney equation has the greatest impact on drug dissolution? Effective surface area of the drug particles, thickness of the diffusion layer, diffusion coefficient of drug in solution, and saturation solubility of the drug in solution. Thickness of the you said B. Thickness of the diffusion layer. Maybe Hiral, can you remember what it was? The principle of the equation in drug dissolution.
Okay,
What
so it's
about the
saying,
surface area?
Yeah, sorry, I think it's surface area. I think it's A.
it's saying it's the rate of mass transfer of solute molecules by ions through a static diffusion layer is directly proportional to the area available for molecular migration and concentration difference across the boundary layer and is inversely proportional to the thickness of boundary layer.
So the surface area.
It explains the rate of dissolution when the process is controlled and comprising of no chemical reactions.
Okay, I'm also seeing that it depends upon the solubility, the concentration of the solute in the solution, and the surface area of the solid.
So surface area, solubility, and the concentration of the solvent.
Yes.
I think
So,
it depends on the first three except the last one. Like even if when you say the surface area, the greater the surface area, the faster the dissolution. So this can also be increased by micronization. Then for you have the diffusion coefficient. So the greater the diffusion coefficient, the faster the dissolution. then the surface area. The greater the surface area, the faster the dissolution. Yeah. Then what else is there? The concentration gradient. The greater the concentration gradient, the faster the diffusion. And then the thickness of the stagnant layer. The more the thickness, the lesser the diffusion.
So we go for surface area of the drug particles. Shrina,
I
what you
think
explained. What you explained.
I think all the first three make sense. The last one is odd. Like the first three have a impact on the dissolution.
As in,
So
they
the
do have
question
an
is asking the
impact.
greatest impact. It's not asking which one does not have an impact on dissolution. It's asking the one that has more impact compared to others, and it's the surface area.
So we go with surface area.
Yes.
Okay. Arrhenius theory is employed in long-term stability testing, accelerated stability testing, intermediate stability testing, and stress testing.
Long-term stability.
Accelerated testing.
I am assuming, I am not sure.
Okay.
Hello. Can you hear me?
Yes, we can hear you.
Accelerated.
Oh yeah, it's accelerated stability testing because the Arrhenius theory relates temperature and how it affects the rate of reaction. So it's accelerated stability testing.
Okay. B. The concentration of a steroid in a formulation is 20 milligram at a time. Is this 0.16 milligram every
Times zero.
Oh, it's 0 and 16.
So at time 0.
At time 0, 16 at day 7.
Oh, okay. Times 0, 16 milligram at a day 7 and 12 milligram at day 14 and 8 at day 21. What order of reaction does the decomposition follow? Yeah, I expect this one people to be answering it fast because we did it again and again.
0. Is it 0?
Not
There is a
Yeah.
constant amount being released.
the concentration of the reactant is not dependent on the elimination. So 0. In which proportion must 10% alcohol and Shrina, we can go with 0. In which proportion must 10% alcohol and 90% alcohol be mixed to make 500 ml of 50% alcohol? Can you explain on that? And that's zero. So we said for zero order reaction, the reaction is like it's independent on the concentration of the reactant. The elimination is independent of the concentration of the reactant. Yeah.
Perhaps just to add on the same, is that for zero order metabolism, we see a constant amount, emphasis on amount, a constant amount is eliminated per unit time. So we can see at the 0 to 16 mg, at day 7, 12, day 14, 8. So we are seeing every 7 days, it's just 4 mg being eliminated. Yeah.
Okay. So it's not at a constant percentage. It's a constant amount that's been eliminated.
Yeah, had it been first order, it would have been a constant percentage or fraction. So perhaps it was 16 mg, then it goes to 8 mg, then it goes to 4 mg, 2 mg, like that.
Okay. We say the drugs that undergo is zero order is phenytoin, aspirin, and was it phenytoin, aspirin, and alcohol? If I'm not wrong.
Yeah.
Okay. Which proportion must 10% alcohol, 90% alcohol be mixed to make 500 ml in 50% alcohol?
B.
Have to have.
Go on.
Oh, the calculation, allegation. So allegation, you remember we have, it's like a map or something like that, where what you want to achieve, which is 50% shall be in the middle, put 90% on the far left, top, bottom left, put the 10%, do your subtraction in diagonally. So 10 minus 40, 10 minus 50 will be 40, and then 90 minus 50 will be 40. The new sums, the new values you're getting, that will give us the total number of parts. So the parts is 40, 40. So 40 over 80 times 500 should be 250.
Okay, thank you. Can you write it on a paper and send it to the group?
Okay.
Yeah, thank you. Which one of this is not a colligative property of a solution? What top left diagonally back right? Okay, I think that was the equation that someone was discussing before. Yeah. So Hannes, please explain the concept as like handwritten dot which of the following is not a colligative property? We had discussed this: osmotic pressure elevation, boiling point, freezing, yeah, so dissolution. Our characteristics of a deflated suspension include rapid sedimentation, large sedimentation volume, sedimentation of practices in loosely associated clusters, and likelihood of caking. Remember those differences.
B.
With caking, you say D or B? Yeah. Rapid sedimentation, these other ones are for flopilated. Yeah. Which of these excipients? So we had covered that. So you can just revert back to the group for that differences. Which of these excipients is correctly matched with its function in tablet formulation? Lactose, lubricant, magnesium stearate, filler, colloidal silicon dioxide, glidant, and mannitol disintegrate. we need to discuss? Have we discussed this before? We can continue.
Okay, just say that lactose is used as a filler or a diluent. Magnesium stearate is either glidant or a lubricant. And mannitol, I think, is a filler. And I don't know the other function of the mannitol.
Okay, thank you. Eutectic, yeah, that word is described as a mixture of cis and trans isomers in equal proportions, solid that's characterized by long range positional order, chemical entity that's crystallizes in different crystalline form, and a mixture of compound which melts at a lower temperature than melting melts at a lower temperature than the melting point of either of the compounds. Guys, even me, I don't know how to pronounce the word, is hard. So what are the definitions? Please, Palestine is saying D. Maybe you could explain it to us what this system is about and everything. So what's this definition? Yeah, you can write for us the definition so that we can read. We have like 10, we have like 3 minutes, so we can finish on this. We can finish. Yeah, but let's someone explain for us what this is about. The system is a homogeneous solid mixture of two or more substances that form a superlattice that melts or solidifies at a temperature lower than any of the individual ingredients' melting point. Should we do one last question?
Maybe we can just even finish this paper.
Finish. How many questions are remaining? Yeah.
They're just till 100. Whatever, we can finish them and then continue.
Oh, it's still
in the
until
next
100.
section. Yeah.
I'm seeing that 22 pages.
But the others are SAQs.
Oh, okay. So then we can finish this up. So in the next question, in lyophobic colloids, viscosity are much higher than the viscosity of the vehicle. Pseudoplastic flow is predominant behavior. The viscosities are comparable or slightly than those of a vehicle, and there is high shear thinning tendency than in the lyophilic colloids. Okay, yeah, Hannes has sent the equation, so you can look at that later on your own. For unless like someone wants him to explain while he's here. So for 93, what do we say? Even Asman has sent a calculation. Back to 93. People are tired. Mimi says C. Someone else says D. Mko na explanations. Even ChatGPT says C. So you can go with C. There's a difference that's sent, so you can go through that later. Which of the following characteristics is associated with lyophobic but not lyophilic? Light surface free energy that's rapidly lowered by salvation, spontaneous dispersal process, easy reconstitution and intrinsic stability. 9D, not sure. Lyophobic alcohols tend to show shear thinning behavior as their viscosity decreases, while lyophilic colloids may exhibit shear thickening. So lyophilic thicken shear thickening, lyophobic shear thinning. D is right. Kiko, you're sure, ma? Hiral, have you understood the differences that you sent? Maybe you can explain it to us.
Okay, from what that has just been sent on the chat by AI, that means that D makes sense. There's a greater shear thinning tendency compared to lyophilic. But I'm not sure. Maybe D is the answer. We can just mark that question.
Okay, D, then you can mark. No, for 94, not 93. Okay, no, wait. So the 93 is D, Hiral, you said D, or it's okay, 94 D also. You also said 94 is D?
That's what I think. I'm not sure. I just know that the lyophobics, they're less stable compared to lyophilic, but I'm not sure about it.
Okay. Which of the following approaches of raising filtration rate may result in a decrease in bed porosity? Those- Okay, then if I think people are tired, D 94D, they already said that. So people are tired, I think we just stop at that because we're not even getting answers. We can just finish on those 5 questions. 8. Thank you guys. Bye.